All right, so we're doing our first Computex show for the show, which is Montech. And Montech has blown their entire budget on the memory that goes in these computers they're showing off today. Normally it would be the booth itself. This time it's the RAM. There's look at this. There's 4 entire sticks in there. And then there's 4 entire sticks in this one too. And unfortunately for case companies, the way to deal with the memory situation is basically to try and get the cost down as low as possible. So one of the cases we're looking at is a $60 case with 4 fans, which is promising, because if you need an extra $400 to buy RAM, pulling 40 of it from the case will probably help. We also have an extra piece we're gonna add, which is talking on the production side, some of the technical details.
Yeah. We will use, like, we call it a continuous stamping.
Continuous
so
stamping.
It is like a long way and keep sanding the metal, and then pom, 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 pom. And then you have a final product.
Kind of like what we've done with Rob Teller in the past, some of the other people in the industry, Tenzin from Fantex, to get some more information on how that all works. The cases are pretty interesting though, where this one is the F738. So they have this open-close mechanism at the front where you can kind of do like a 45 degree, I guess, a full open or a closed. I'm really interested in testing this for flow and acoustics. We know this is going to perform worse, obviously, but the point is that I guess with our chamber, we actually can get the resolution we need to see if there's a difference between this 45 degree and full open. And historically, like that testing, we would not have had the resolution to get that data. So I'm excited about that, because from a testing standpoint, that should be pretty cool. It's running 2 170s for the front in one of the variations, so there's 2 SKUs. The 2 170s is something that Lee & Lee has played around with a little bit, and they've been very successful with the performance on theirs. So 170 has been a good performance. Very uncommon size, obviously, but kind of maximizing the space without blowing it out with the 180. These are also 30 millimeters thick, so that should help with static pressure performance. And then the cases, depending on if it's the glass version or the mesh version, it's $100 or $110. Kin95 3D. So this one's mostly interesting because they've got this recessed sort of fan tray on the side. Ventilation is going to be on the side panel. And then the cheap case is this. This is $60. This is called the TG3. And this one's mostly just interesting because it's $60, but it does have a unibody 3-fan sort of shroud housing over here, and it comes with a rear fan as well. So 4 total fans, all 120s on this. The curved one, which is this one specifically, is 90. I think you're going to see this as the trend at the show, which is that case companies and cooling companies specifically have absolutely no control over the greater market conditions, which we just talked about in our documentary. A lot of them are trying to deal with that by bringing their price down to try and compensate wherever people can. All right, let's get into it. Before that, this video is brought to you by Thermal Grizzly and their new Duronaut thermal paste. Thermal Grizzly claims its Duronaut paste is intended for long-term stability and endurance, focusing on paste longevity in addition to the usual performance focus. Thermal Grizzly's Duronaut paste comes with applicators and spreaders, and ships in numerous tube sizes, aiming to provide a high-end paste for PC builds and daily driven overclocks by enthusiasts. Learn more at the link in the description below. All right, so we'll start with the F738, which this case, I guess the interesting kind of gimmick they're doing here is making it floating, where you can see, obviously, there's kind of a lower chamber and an upper chamber. On a technicality, I guess it's a dual chamber case. The support's entirely at the back. I think externally it might be a plastic cover, but then internally they're using steel as the actual support for this. This is removable, so this is a support mostly, I think, for shipping. It can be taken out by just pulling like this, and then that will turn into a phone stand, I guess, is kind of the idea with that, whether you use it or not. But it definitely still adds support. It is absolutely doing something. How much that matters probably just depends on how heavy the system is and if you're ever going to touch the corner of it. I mean, if you like lean on this, that's probably not great. But it is removable and obviously can be left in for additional support. But the floating thing is what they're trying to do new here, other than the opening closing grill at the front, which this is also aluminum. So that is going to be on the sort of the more expensive end of material choices versus just the pure plastic play for it. Those are really the 2 main things with this case, other than the 170s, the 30 mil thick 170s. Otherwise, we'll take a look at the back, but a couple features here that are noteworthy. This is just a cable cover, so small attention to detail stuff, that can be removed and just hides all the cables in this deeper channel here, which is helpful. Power supply is in a somewhat standard position. These grommets were also somewhat noteworthy because they've got this like strainy approach, which you might remember that from Haven. I think it was the BF360 that did something similar. Otherwise, I mean, back connect support, like a lot of cases these days, relatively wide channels for the EPS, 12 volt. The Vision version of it is going to come with 2 120 side 120 rear. Since it's floating, your bottom intake obviously ends up being elevated and more in the middle. Still goes straight into the GPU. They're saying that the plan is, although it's not ready today, to add a magnetic dust filter to the bottom of this, since it is going to be intake, so you'll want to filter that. So there should be a filter by the time they're done. In terms of airflow characteristics, to me, the most interesting thing that we'll have to check in testing, because I can't really guess too accurately at it, but what I'm interested in is, obviously the GPU should benefit a lot from bottom intake. They always do. Air is going to come in straight here and go into the fans. If it's a little more negative pressure back here, you're going to have intake from this rear ventilation as well, and through the punctured PCIe slot cover straight into the GPU. That tends to be beneficial. What I'm curious about is up here at the front, because this is intake, and because there's going to be some pressure from over here with the GPU fans, I'm curious if some of this will find its way out through the bottom and out of the case, where it wouldn't be that effective. So for that, probably we're going to do a test where we just cover this, once we get it in for benchmarking, and see if it changes the characteristics. Now, overall, this should be a good performer as long as the front's open, just because it's two big fans that are right next to the GPU and a tower cooler, so it should be fine, but something we're curious about. Last couple things for that 738. So the screen that you see on the side, that can become that'll be a steel plate by default, so that's not included. And then target for that is September, October timeframe. So the TG3, this is supposed to be June or July, and there are two SKUs for this. This is the more expensive of the two with the curve at the front, and then the LED strip here, which you can see these two models have, whereas the $60 model does not have the strip and doesn't have the curved glass. Otherwise though, same tooling. This is all brand new tooling for them, so shouldn't be repurposed from anything. Of note, I guess, it's got the unibody fan, which is new from Montech. These I'm kind of mixed on. I mean, I think our audience can pretty well predict the things that we don't like about unibody, which is that if you have a fan die or an RMA issue, now you got to RMA all three fans. But it is, it looks a little cleaner. In the past, I got some numbers from one of the other case companies that said, depending on how it's done, it can be a little bit cheaper to make a unibody, but it just depends where they go with the tooling. Because I know some of the unibodies that Height had been working on that they didn't ship were way more expensive than doing just standard fans. So it depends on the design. But the TG3, the main thing they're targeting is just the price. So at $60 for this model, of note, I guess, you've got this sort of titanium colored power supply shroud. It's fully perforated on the front, side, and top, which is nice. Standard cable pass-throughs in the back for GPU power, USB 3, HD audio, all that stuff. And then the white version is just a white power supply shroud, but the same thing. They have the RGB strip on the $60 model, and then I/O at the front, pretty basic here. So 2 USB Type A, 1 Type C, and combined audio. Clearance on the bottom is not that much, but there's not going to be bottom intake on this case. What Montech did note, though, is that this large gap in the front of the case, I guess, could be used for figurines and stuff. So this was like the sub-meta that was emerging from Computex last year. Trikes had that case with a display stand at the front, and Cooler Master had I think they call it the stage with the display stand. So I guess there's space there if you want to put stuff in the front. So 4 fans and cheap. I think that pretty much covers most of it. We'll look at the back side really quick though. Just a steel panel perforated for the side for intake. And there's a bit of a curve here, so not the craziest amount of cable management space. But it's got the cheese grater motherboard tray, supports back connect, includes this hub for RGB connections. And then, otherwise, I guess your cable channel, your main channel is going to be here. You don't have a lot of places to hide it with the back connect motherboards, but a motherboard, ATX board will cover that anyway, so we'll kind of hide it from the front side by default. And everything else is standard here. This is similar to the HSO1, HSO2 fan from what they were telling us. So there's standard and reverse blade variations, but the change they've made from the HSO1 and 2 are, those fans had they're saying a slight rattle. I'd have to look at our review and see if ours did or not. But so they've changed the swoop of the blade towards the outer side of the frame to flatten it a little bit to try and help deal with that noise. But otherwise, these should be pretty similar. Should be a polycarbonate blade, and then a 30% fiberglass injection for the frame with PBT. So that runs us through the fans. They also have a Lian Li-esque fan. So this is new as well, where It's just the daisy chained. I actually asked about patents on this because some of you may remember we covered the patent lawsuit when Lee filed against Fantex and Thermaltake. Basically, the specifics of the patent were that Lee, they didn't patent daisy chaining. They tried to patent specifically LEDs on a fan with power in on one side and power out on the other side. And so I haven't checked on the status of that lawsuit. I've been told that Lee lost. We'll follow up on that when we get a chance. Because the first question I had for Montech was, how do you deal with the getting sued part if they do that? And it sounds like Lee may not have won in their suit, which, I mean, honestly, it was kind of a stupid lawsuit anyway. So this is the King 95 3D. So this one's pretty interesting, mostly because they've gone with recessed fans for the front here. So these almost perfectly line up with the motherboard tray. It's like proud by 0.5 millimeter or something. And then there's this thing that can socket in here if you wanted to add a third fan up top, and that should fit flush with the two below it. The side panel is fully ventilated, so you can see here it's got the angled grill, and then fans can mount above the motherboard tray and also, of course, to the side. So this is all punctured. This is punctured for the power supply, and let's just take this out too and look at it. In terms of the panel, it's got one contiguous filter here that's removable, and one here. I think actually we'll come back to it, but I had a point about this case where in pursuit of going lower cost, you'll notice that the dust filter for the TG3 is, I think it's plastic welded. It's basically melted to the plastic. So this is not removable. And if it's exhaust, it ends up just kind of obstructing exhaust. It'll lower the performance slightly. In our testing, we've seen sometimes a couple degrees at most. And since you can't remove it, you wouldn't be able to fix that. But we're going to talk about this a little bit on the manufacturing side, what some of the reasons are for cost control and how it impacts the pricing. Anyway, these are removable. The rest for the King 95 3D, this is for their 10-year anniversary. Montech is supposed to come out on December 5th, I think it is, which is when the King 95 came out. And it was Montech's biggest success that they've shipped to date, they said. So it can fit 3 120s in the bottom, which they've got here, 2 120s in the rear, basically just a bunch of holes everywhere in this case, so ventilation's good, despite being glass on all sides. And then 2 120s on the side with a 3 if you do the expansion. They don't include, although it's shown in some cases, the GPU riser and vertical stand. That would be separate. Otherwise, it's just a horizontal GPU. Motherboard tray has fairly deep cable management space just because the front edge comes out so much to accommodate the top mount fans and radiator. There's a lot of extra space back there for cable management. This can fit a 360 up here. So kind of interesting. I mean, I don't know that I've seen a whole lot of, we have seen some cases I think that do this, but haven't seen a whole lot of cases that do a radiator mount on the side like this directly above the motherboard tray. I want to say MSI might have done it on one of their ridiculous cases, but anyway, it's an interesting case. So this one's going to be $120, no fans included for this, and I think that pretty much covers it other than the wood version of the 10. This is all the same as we've already looked at. It's just using, on this model at least, a walnut, they were saying, and some wood accents, and then a kind of gray colorway, which looks nice. So that covers the products. All right, so now we're gonna get into a technical discussion where we've done this over the years with a bunch of different companies. Ray from Montech, you are a products manager?
Yes.
Is that right? Okay. So you deal with a lot of the decisions on manufacturing and how do you actually get something made once you have the idea. This filter, I guess, was, before we were filming, I asked you guys about this where I said, I'm not a big fan of a non-removable filter. It is a $60 case on the far end, so obviously that plays into it. Walk me through the basics. I mean, what are you considering?
Okay, so if we start to calculation about a cost, because we need to invest all these parts, right? So the most difficult thing is the tooling is a huge cost. We call it tooling cost. And another one is for different pieces. And one structure, if we use another removable plastic filter, it will become one extra pieces and one extra tooling. So it's definitely, the cost is different. So we normally can see this kind of design.
So it's
actually
from the 10,
the
right?
10, the front mesh. So there's a metal mesh in the middle. So we use a plastic frame. So this one, we will call it two-piece design.
Okay.
This one, if without lighting, we will call it one-piece design.
So what kind of cost difference do you run into?
20% to 10% difference.
Okay,
Yeah.
increase, yeah.
Yeah.
Is the main reason for that time, or is it the tool itself? You know, because the tools, I guess, my understanding is normally case companies will amortize the tool cost over the run of cases.
Yep.
Is that right? Okay.
Yeah.
Because tooling, you know, you don't have to give specifics for this, but do you want to give people a kind of an idea of how much tooling costs, like a range?
A range?
Yeah.
It's around, usually because it's different size,
Yeah.
based on different size.
So if we take like a generic ATX case, you know, low end, high end tooling costs.
It have to also depend on like how much the stamping you want, how many process, and also the thickness of the different metal you are choosing. And there's also SPCC, SECC, different quality.
Type of steel.
Type of steels. So if your thickness is thicker, your tooling, we call it tons. The pressure itself have to use like huge force
Yeah.
to make it to different shapes.
Does that require a different machine?
Yes.
Okay.
Different machine and different costs.
So I'm guessing the higher pressure or higher force machines
Yes.
are less common or more expensive?
More expensive.
Okay.
And if you have a lot of like MOQs, like PCIe,
Yeah.
we will use we call it a continued stamping.
Continuous
so
stamping.
it is like a long way and keep sending the metal
Yeah.
and then pong, 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 pong.
Yeah.
And then you have a final product.
Right.
That maybe like 12 different steps
Uh-huh.
by one single arm.
Okay.
Keep stamping.
Because we've seen like I don't know, I'm sure they make different ones, but like the silly green machine
Yeah.
with the big spinning thing at the top.
Yeah.
And it's normally a continuous line, right? It's just like, and then you get normally like PCIe slots or whatever out of that.
Yes.
I guess, does that not work for like larger panels or higher force applications?
Yes.
So you have to switch to.
We have to switch to like stage by stage. So
Got it.
if you are fully automatic,
Yeah.
there's a robot arm in between.
Got it.
So the first one stamping, and then use robot arm to the second station, and then stamping, and use the arm to third, to fourth, and to finish.
So are you? I guess for context for people, Montech doesn't own its own factories.
No,
right?
we don't
Like
own.
most companies don't. So, are you guys? Is the cost normally like paying for the machine time at the factory, or is it extra manual labor? You know, like.
I think the first impact, extra manual labor is the first priority, because right now even China, the labor is cost higher than before.
Right.
And then the second one is, I think, is the different process you are dealing with. Like even with the robot arm, the one extra stamping means extra cost.
Right.
But if you have higher MOQ, the extra stamping costs lower than the thickness, reduce the stamping. It's not really good for cost.
Right.
But if you have high quantity, more stamping, and reduce the material cost, it will wiser, because the whole cost and value is more cheaper.
Okay.
Yes.
We didn't get in on this earlier, but one of the other things I pointed out was this bar covers a lot of area if you were to put 140s in
Yes.
here. And we've talked about this on other cases, but you can fit a 140, but you've got this metal sheet. So like in a perfect world, this is not here. You need some kind of structural support though. So your next option would be perforating it. But this gets into some of the tooling and stamping. Do you want to explain, the decisions?
Yeah, actually, my personal experience for the top radiator or bottom radiator is if we have an extra bracket and the top is a huge long hole, like rectangular hole or round
You're talking
hole.
about like a removable?
Yeah,
Okay.
so removable bracket, then I can screw the radiator on a bracket and then use a bracket screw back
Right.
to the top panel. But that require an extra piece,
Right.
even 2 extra piece to 3 extra piece to achieve that. So the cost will become a huge difference. If you compare one piece to extra piece, there's a 3 times or 2 times difference.
Okay.
Yeah. So the
Pretty
cost,
linear.
Yeah, it's huge difference. So usually you can see these long stripe holes. We can punch almost on a same process. So we call it stage on a same stage. Like this long hole, maybe not the 100% of these holes,
Yeah.
maybe 80%. So we can separate to 2 different stages.
Okay.
Yeah. But if you are seeing this rear panel, we usually have to separate 5, even 3 stages, because if we stamp in all of them, the structure will soft.
Okay.
Yeah.
So is that because it starts warping, I guess?
Yeah, and deformation.
Right.
Yeah.
So what? So if you're stamping this in multiple stages, is it just like whatever every other hole or something, or how do you split up the tool or the stamp?
Like usually we call it the first die cut, like a paper, right?
Yeah.
So we first is similar to die cut. You cut the edge, edge, but it's flat. So maybe we have to certain like angle we have to like flip over.
Yeah.
That flip over we can hide some different holes together. Then maybe the next stage is for these pumps, so we can hide few more holes. Yeah. And to process together.
So when you flip over edges, or when you have like something like this, right, where this comes up higher than the base.
Yes.
What is this part of the process? Is that
it's also stamping, but this one is stamping and like cutting.
Okay.
And this one stamping is like just a bump.
Got it.
Yeah.
Okay. Is bending a different process?
Yeah, the same process, same machine, just different tooling.
Got it.
One tooling is like a mold. One is male, one is female, punching like this. Another one is directly die cut and cutting. Yeah.
And I guess the tools are only like large steel pieces, and they just mount to the machine.
Yes.
Okay.
Yes. So actually, the center part, we cannot really see it.
The white one's going to be easier for him to film.
Okay. So actually, you can find out the center part. These pieces are 1 millimeter thickness. Yeah. And this motherboard is also 1 millimeter, but maybe this for the decoration, the fine mesh is 0.8. Okay. So because we need to keep the cost balance. Yeah. So the main structure we use like stronger steel. Yeah. And use the thickness to increase the strength, the hardness. Yes.
Right.
Yes.
Is this challenging to do at all? This curved.
We punch the hole first, then we make it curve. Okay. Yeah, but the Corsair one is the 3D mesh is more challenge.
Yeah, like on the frame series, right, where it's got the Y. Yeah, I heard that was.
So usually, if we use like thinner metal, we will create this pump to increase the strength, the hardness.
Okay. Yeah, that makes sense.
Or we will use this kind of rolling edge.
So this type of thing, I guess, is a trick to help with the metal, compensate for the metal thickness. Yes. Got it.
If you are just like a flat pieces, it's like a paper. Like, you can rolling, But if you create a bump or even an edge, for the edge, right, and it was stronger, like a C-shaped corner. You cannot really bend it. Right.
Right. What, out of all the cases you've worked on, what was the most challenging from a tooling perspective? You know, like manufacturing, tooling. What one
I will say the mesh.
Okay.
Because the mesh is the most difficult thing. Because like if you are creating a mesh on this one, the mesh itself, how to say the punching, the punching head or tooling itself is so small. So you have to do this punch maybe 5 different stage to finish, allowed to finish.
Because otherwise it'll bend, I guess.
Yeah, and if you after you punch the hole, you want to like make it on different shape. That require another different stage, and also we will have the chance to deformation. Okay. The mesh itself.
When you have like a defect that the factory makes, you know, that they just throw out or whatever.
Yeah, throw out.
What type of defect do you normally see? Is it?
Like the hole here, so you can, if you have a ruler or something, you can find out maybe this one is 1 millimeter and here is 1.5 or 1.3 millimeter.
Okay.
Yeah.
Cool. Very cool.
And if this shape, like other company, if have more difficult shapes, not only hexagon or not only triangular, you have maybe one hexagon, one triangular, and keep repeating. That one is most difficult.
Okay. Why is that?
The pressure is different. So because different shapes require different pressure. So if you like triangular, maybe the 4 corner is the
So are
stronger.
you doing like, do you do geometry when you're designing? Like, basically, does the factory tell you, hey, this is going to be hard, or do you guys prepare for it to be difficult and engineer it in advance? Do you know what I mean? Like,
It's normally like both way.
Okay.
Yeah, they maybe have some really hard, difficult stuff in the before, so they will tell you advance. But sometimes it's because we design, we try, we fail.
Right.
Yeah.
Right. And then you work with the factory, I
Yes.
guess, to figure it out. Okay, cool. Very cool. Anything else you want to go over? Or you think we got all the interesting stuff?
I think we got all the
Cool.
interesting stuff.
Okay. Thank you for joining.
Thank you.
And we'll have more Computex coverage all week. So check back for that, subscribe for more. And that's what we got for Montech. But we will see you all in the next video.